is the video lesson for Introduction to Magnetism. The learning target for this lesson is I am learning to understand how magnetism works and to describe what happens when magnetic and electric fields interact. The success criteria for this lesson are: I can understand the atomic structure of magnetic materials. I can describe how magnetic field lines look and interact. I can describe how a changing electric field creates a magnetic field. And I can describe how a changing magnetic field creates an electric field. So what is a magnet? So a magnet is any material that attracts iron or iron-containing materials, including other magnets. So magnets generate a magnetic force, similar to how charged particles generate an electric force. Magnets always have two poles. So we have North Pole and South Pole, and like poles repel each other, and opposite poles attract each other, similarly to the way electric charges work. So we know what magnets are, but how do magnets work? So in certain materials, which we call ferromagnetic elements, the atoms all line up in such a way that protons and electrons are aligned to create a strong magnetic field. So we have all these areas inside an element, and they line up such that the positive and negative areas within it are mostly aligned, so that the positives and negatives are all pointing mostly in the same direction. So elements like iron and nickel and cobalt, these are all ferromagnetic materials, elements that can create magnets. So all magnets have two poles, from the largest magnetic object, like stars, which have magnetic fields, to the smallest objects, like subatomic particles, like inside of an atom. They all have two poles. So you can see here we have a diagram where we have a large magnet that's broken up into two smaller magnets, which have a north and south pole. Then those smaller magnets are broken up into smaller magnets, and each smaller chunk has a north and south pole, all the way until we have this atomic object here, an atom, which also has a north and south pole. So again, when a magnet is broken into pieces, the pieces have two poles even. So here we can see the field lines for two magnets that have the like poles pointing towards each other. So the north pole pointing towards the north pole, and you can see the field lines repelling each other. So they're bouncing off of each other. So when you try to put a north pole against the north pole, they repel each other, they push off of each other. And you can see the field lines here really repelling each other. They're really moving off and fighting each other. And this is similar to the way electric charges work. So electric charges and magnetic, so electricity and magnetism are two sides of the same coin, which is why they look so similar to each other. And here we have opposite poles attracting each other. So here we have a north pole and a south pole facing each other. So these two magnets are going to pull towards each other. So we have the field lines from the north side, from the north pole, attracting, moving towards the south pole. So all of these field lines from the north pole going to the south pole, and you can see that the field lines from the north pole of the same magnet are attracting to the south pole of the same magnet. So here we have a north pole going to the south pole. Here we have a north pole going to the south pole of the same magnet. Okay, so a changing magnetic field induces an electric current. So when a magnetic field when a magnetic field moves through a coil of conductive material, an electric current is produced. So if the magnetic field is moving, and that's an important part, then an electric current is produced. So this is how electric generators work. So here we see this diagram here where we have this coil of wire which is spinning, and so the spinning of the wire means it's moving through this changing magnetic field, and as it moves through the changing magnetic field, it produces electricity in these wires down here, and the wires are connected to these brushes which transport the energy, the electricity down here to this light bulb. So this is exactly how electric generators work. You connect something like this. This is a very simple generator. You connect a more robust and complicated generator like this to something that makes this wire spin, like a wind turbine, or like in a hydroelectric dam. You have the water pressure from the dam spinning a turbine. So that's pretty much how we generate most of our electricity. So this changing magnetic field is when you spin something inside of it, the electric current is produced. So similar to the way a changing magnetic field creates an electric field, an electric current induces a magnetic field. So when an electric current moves through a conductive material, a magnetic field is produced. So if the conductive material is wrapped around a ferromagnetic material like iron, we have an electromagnet. So if you took a nail or a screw and you wrapped it with a bunch of wire, and then you attached it, and then you ran a current through that wire. So we have current running through the wire. This becomes an electromagnet that can pick up, say, paper clips. So this is how an electric motor works. You apply a current inside, so you have these magnets here. These magnets. You've got this coil of electric wire. You apply a current to this coil of electric wire, and it spins inside this magnetic field, and that is what drives the electric motor. So the changing magnetic field induced by the current causes a coil of wire to spin. That is what happens when inside of an electric motor. Okay, keep asking questions. It's how you learn new things.